When you're trying to determine if a number is rational or irrational, always turn the number into a decimal. If you do this, then you'll be able to follow a couple of easy rules. First off, we have what's called a terminating decimal. That's like 0.2 or any other decimal that just stops. We also have what's called a repeating decimal. That's where it repeats in some sort of pattern, like 0.3, same thing as 0.333, and it just keeps going, but we just use a repeating bar to show that. And then we also have the situation of a decimal that does not repeat. So basically, if it does not repeat, it goes on forever, but there's no pattern. And that's what it looks at. You take any number that you have, you turn it into a decimal form of itself, and if it stops or repeats in a pattern, it's rational. If it goes on forever and it has no pattern, then it is irrational. So 0.3 or 3/10 is already in decimal form. It's terminating, it stops, it doesn't keep going, so it's rational. 1/4, how do we do that? 1 divided by 4 makes it 0.25, so that's a terminating decimal, it's rational. Square root of 101, you know what? It's not a perfect square root, so that decimal is going to go on forever, but it's not going to have any type of pattern to it. That's irrational. If you don't believe me, check it with your calculator. 78 hundredths, terminating decimal. So that is a rational decimal. Excuse me, a rational number. Even if it's repeating, it's still going to be rational because it's repeating in a pattern. The square root of 36 is 6. Well, what's 6 as a decimal? 6.0. That's still terminating. That's rational. 5 as a decimal. 5.0. That's rational. Pi. It's basically going to be 3.14, and then it just keeps going forever and no pattern, so that will be irrational. Negative 4.0 is still a terminating decimal. We don't care if it's positive or negative. That'll be rational. Same thing over here. And even if it was repeating, we don't care. It's a repeating decimal. We don't care if it's positive or negative. That is rational.